All right. Yep, here we go. So yeah, so this we call it AEC developer meetup. Welcome again. It's going to be mostly me with some technical backup from two engineers of HOOPS Communicator, Vincent Thibault and Stefan Calais. I hope I pronounced their names right. So just to go on to the next slide, just a quick overview. So yeah, quick introduction, that's already done. Then I'm going to actually show three different demos, which talk about various aspects around BIM. Some of the stuff we are working on in the labs. Some of it is already been released. Some of that is still being worked on. So basically, those are all libraries and tools around HOOPS Communicator that kind of show a little bit something that's a little more focused on the BIM side and just being generic viewers or generic libraries. Obviously, all of those are leveraging HOOPS Communicator at the back end, so using the power of Communicator and for AEC BIM. And again, at the end of not at the end of this meeting, but soon, they're already released. Some of them are ready, and you'll get links to those that are already available after this meeting is over. Okay, so very quick before I go on to the first demo, that will showcase a little bit like the concept for a more BIM-focused viewing application using HOOPS Communicator, focused on federated models, each with their own separate model tree instead of just having one big model tree, adding a simple search to the viewer, working with BCFs, how to handle drawings in the context of a BIM application and overlaying 2D and 3D. And then also talking a little bit about the backend that we developed, again, and that's already released, that allows you to easily convert cut models, view models, implements all the streaming backend, and deals with scalability and all these things. So, okay, so let me switch to the actual demo now. Give me 1 second here. All right. So we start off once again with again this BIM, this viewing front end, and that's basically it's an UI that has all the kind of user management and project and hub management that it can already download, and basically it's essentially a SaaS application in a box. So if you're using Communicator, it's a SaaS Communicator backend on your server using this client, you had a jumpstart essentially your application development very quickly. So I'm just going to quickly log in here, username and password. Okay, then I have already made a project. And so compared to our standard viewer, again, the focus is here on model federation. So you see on the left side, there's a tab with various BIM models. They're all kind of belonging to the same project. And I can activate them all, either one or the other, or together. So here that is the architectural part of this clinic model, which is like an open source IFC model. But you can also add like a structural component here, and each of those things come with their own model tree. So you can go in here and have, instead of just having this one model tree, everything combined, everything is separated and based on this structure. And you can organize these different categories and create kind of different things. Yeah, really on the back end, again, using the power of Communicator, using the slowed subtree functionality to easily stream and bring models together. So another interesting aspect is how drawings fit in. In this case, there's 2 drawings here. So you can either, let me turn this off, you can either view them by yourself. This image file could also be a PDF. So those drawings are coming from, from external sources. And the idea is, of course, to overlay them and view them together with the 3D. So here you have the drawing model that we created for this model. And then you can view this, of course, by itself, or you can bring it in and view it together with the 3D. So again, the viewer makes it really easy, essentially, to align a drawing with a 3D component. Here's another one. So this is like the view from the first floor, and then you can have a side view as well. And as you see, it automatically aligns the drawing with the 3D. It sets a camera accordingly, but it's still like 2D and 3D essentially combined. And in order to achieve that, which is of course not quite automatic, but it's a very easy editing process. So you can go in here, you can have these movement handles, so you can position the drawing cut through the actual 3D model with the drawing overlaid, which is of course very useful. Or you can add these pivot handles. And again, that's what's happening when you initially bring in a model. You have to essentially align it with the model. So you would set these pivot handles here, and then oops, why is that not working? That should be. Then here you can see here you can basically reorient, change the position and the orientation of the drawing, and make sure that that's aligned to the model, and that all that gets obviously saved to the model as well. The other aspects, and again, this is already released. It's another library that we pushed out, I think, a few months ago, and so it's very easy for you to add this type of functionality into your BIM application as well. Another interesting aspect is the search. So if we added a simple search here, and in its simple form, so for example, let's say you're just interested in all the space entities inside this model. Instead of having, you can just do this by a single click here. This is like a special button, and then what you get is basically just the individual spaces in the model, like corridor, whatever you want. You can use this this clipping region that we also released in the forum a while back, to actually just clip to a specific space inside the model. So again, very useful. Or turn this off again, and that search happens, of course, throughout all the models that are currently available. This one is not loaded in yet, so we can add this as well. Another interesting aspect, you can search by anything, essentially. So in this case, let's say I want to see all the windows in the model, and then it automatically limits the model tree to only the entities you are searched for. So now you have window 1 and window 2 here as well. So yeah, it's just again, this is like a proof of concept, like an idea of how we can have a little more tailored BIM application, and so this is what we kind of came up with here. And again, we're going to be releasing this soon. Another thing is you have to BIM search. It's BCFs. Of course, BCFs have been added to Communicator and to our standard viewer, I think about two or 3 years ago. But the UI is fairly basic. It was really up to you to come up with some for UI that's more tailored to your application. So for this demo, we made a little more of a UI that is a little more sophisticated and more practical, essentially. So again, as you probably know, on BCF, you obviously have a lot of topics, a lot of issues. So this gives you like a quick overview, colorized based on what's actually an important topic and what is less important. And then, of course, you can go in and activate a specific view of the model. You can look at, and obviously BCF saves not only the position of the camera, but it saves also things like the color of entities. You can add markup to it. So it's really easy to just go through all the existing BCFs, look at what's relevant, or you can go in and let's change the position, change the color here, maybe add some markup, and then you can easily create a new BCF. It gives you then that capability here as well. Again, we looked at other BIM applications, how they do it, so it's not exactly rocket science, but again, this is something that is kind of useful and shows that HOOPS that the Communicator works really well in the context of this type of applications. Okay, finally, going back here. So again, this BIM application is built on top of what we call FAS, Communicator as a Service. It's a service backend, and it's an open source thing that we released a couple of months back. And so it's very easy to do things like model upload, streaming, all this kind of model aggregation that you see here is all handled by a scalable backend that can run on an Amazon or Azure instance, or of course in this case it's actually local. So here, for example, if I wanted to upload another model, I can just click here, and then it automatically handles all the upload. It's going to take a little while to convert. And again, not rocket science, but this is all basically done for you. So it's without writing any code, you can jumpstart your BIM application by just using these toolkits. It's going to take a few seconds here, and then we can set this model here. We can go back to my camera, and then just turning this off as well. And then you have, and then that one you probably want to drag into the MEP part. Yeah, there we go. So let me quickly go back to the slide here and move on to the next demo. So now I'm going to drill it. So this demo also includes some search capabilities, but search in the last couple of weeks and months has really been a focus for us. And so it's another library coming out in the next couple of weeks that really hones in on taking advantage of all the property data and relationship data that Communicator provides to the user in the client itself. So I'm going to show this kind of smart search, smart property extraction, doing interesting things essentially with search. And so you have these properties, but then you can also do very easy reporting, kind of quantity takeoff, at least like showcasing how that could look like and how that works with search. So let me go back to my application, and I'm going to switch to a different application now. So again, this is our standard viewer with this like search capability added, and we have already loaded the Abelada model, one of our standard models that ships with the product. So let's search. At the very basics, it's doing anything, any property, any specific type, any name within a model you can essentially search for with this box. And so let's say, for example, I want all the walls in the model. So all I need to do is type wall here that finds everything. So all the 3 different types of walls, curtain wall, and wall standard case that are in IFC or in this model in particular are going to be found. Just click with one click, they're selected. Very easy now. Of course, you could do this as well using the model tree or using the types tab inside the model tree. So that's not really that interesting. But now, of course, you can narrow the search even further. So let's add another condition here. Let's say we want to find all the walls that are contained in story 3 and story 4. Within this building. So we want to just kind of drill down on 2 specific floors. And again, in this case, we're using this new relationship capabilities that HOOPS Communicator supports. So you can say, well, give me everything that's contained in this model of in this floor, and essentially, and at the same time of type walls. So again, we can hear this here. We can do a search, and then we select on it, and you see here only the walls that are in this floor. We can actually isolate that here and then get all the floors. Okay, let's get a little more sophisticated here and add another condition and say we want to have the height of these walls. We are only interested in walls below 2 meters. So we just go in here, base quantity height, and then we say we want to have kind of less than or equals 2 meter. That's in millimeters. So yes, so do that here, do another search, and you see now we get all the smaller walls in the model as well. So, and let's drill down even further. So let's say we have all the walls below a certain size, story 3 and 4, but we also now want to know only the walls that are actually in part of the kitchen space. So again, very easy. We use relationship again, IFC space boundary, and we say kitchen here, and boom. Now we only see the walls that are part of the kitchen space. So really powerful. You can do and or searches. You can have these condition groups. You can combine things. So for drilling down and aggregating things inside the model, this is really a very, very powerful piece of functionality. And now we can add this search here. We can put this in this box here, and now that is basically saved. And hold on for 1 second here. And we can always get back to it. So if I have to reset the model again, and click on this again, it will find these walls again. And the power of that, of course, is that this is not baked into the model. It's a dynamic search. So if you have a new model, if you have a new version of the model with a different date, with slight changes, this will always give you the correct results back. And now we can do something else that's kind of interesting. We can say, well, let's do this here, right? Let's find let's actually change. Let's go back here. Let's do this for the complete model, not just floor 3 and 4. This makes it a little more interesting. So now we get all these small walls here, and let's say we want to turn those yellow. Okay. Yellow and opaque. And now bear with me here. And now I make another search that I can add here. Put this in front here. Isolate and transparent. And then I can just execute these two things in a row. And then with a single click, it automatically highlights all these very specific walls inside the building. And again, you can save that out. You can bring this back in. And so if you're using a different model or a different version of the same model, it is a really powerful piece of functionality. Another interesting aspect here, let's reset that again, is that you can turn this also into like called a smart property. So once again, now we are inside the building. We see the kitchen here. I'm activating this, turning this into a property. Give me 1 second, I need to move something out of the way. And now when I'm selecting a wall and the wall happens to be part of the kitchen space, you'll see that automatically pops up here. So again, it's essentially another property that is added alongside the existing properties. So if I click on this wall element here, of course I get all the regular properties that are part of the IFC model, but this is one that is dynamic and based on your searches. So again, just by clicking on the entity itself, it gives you that piece of information, and you know that this is a small wall that fulfills this criteria. Let's try one more quick example here for the search. Let's go back out here. Now in this case, let's do the same thing, but for doors. So again, go for the door. In this case, get all the doors in the building. Very straightforward. Let's say doors have like a specific property operation type. Okay, so you can see it's already pre-populated. There's 6 different operation types in this for doors. So we can now say, well, we only were interested in this one type. Click on it, and then that limits it to only those doors that are, in this case, like double double folded or whatever that means. So that's one way to look at it. But of course, there's a different, more interesting way that allows you to drill down into the data. So instead of like specifying a specific type here, we can also do a search and then create a report from this data. And it gives you and then when you look at this here, boom. In this case, let's say we combine this with a layer, and the other type is this, and let's see what happens there. So now that is basically a port of all the doors with their different styles. If you can say layer, let's actually use the operation type here. This may be better. So now you can get here an overview of all the operating type. How many, you get a count of how many are in the model. You can quickly like switch between them. Let's actually visit that model thread first. You see all the different types here. You can colorize them. For example, you can give them all a random color, and then that gets applied to the model. Okay, let me, now you have all doors, each of them with their own color. So again, for reporting purposes, if you want to do some limited quantity takeoff, or at least drill down into the details of the model, this is a very, very useful feature. You could also, for example, organize this by height, for example. Let's try this again, generate, and then here in this case, and then you can assign a gradient to it. And then you see that the doors are now organized by their position within the model. So there's a lot of things you can do. You can drill down on individual pieces. Here you see like these models are all in the same kind. You can drill down on this particular category and then look at the individual pieces or individual parts that are in this model as well. And so yeah, it's this is all, again, a library you can download. It's going to be released in the next week or two, and it makes it easy to plug it in. It has a UI component, but also all the backend for searching stuff. So it's really easy to build your own UI around it and integrate it into your application. It's also, again, it leverages Communicator, all this relationship stuff, very quickly being able to search through the properties. All that is kind of really using the power of Communicator on the back end. Maybe one other example with a different model that obviously it works very well with IFC models, which have these additional property and relationship type, but also you can use it for Revit, for example. So here, let's go through like a quick example on the Revit side. And here, let's say we want to find all the windows in a model. So very easy. Let's look for layers. In the case of Revit, there's a model, a type of entity is usually in the layers itself. So here you say, let's say window is right here. So we can search through that. But, interestingly, that only gives us a small direct windows here. These things here are actually not windows. Those are curtain panels. I think that's what they are called here in Revit. We need to look at and that is in the category curtain panel. So for that, we need to get a little more sophisticated with the searching. So let's say, we include all the things that are layer windows, then we add this condition group and we say or, and we add the layer curtain windows, curtain panels, and then we also add the condition, and there I looked already in this before, go to the materials and finishes. I think it's materials and finishes, base material contains glass. Let me, the materials and finishes, this one here, actually, it's glass. Okay, so now with this a little more elaborate search, do another check. And now when I isolate this, you see that contains actually also the windows that are in the model. And again, you can save this out, add this as a smart property, and then it makes it easy to find these windows, even if you have a different model that has the same type of structure or the same organization. It's a really a cool way to make your application more intelligent and add these capabilities. Okay, let's see. So yeah, we are looking pretty good on time. Maybe a little too good, actually. So let me show one quick demo here that is that you've seen in the first demo, which is like a new different model browser. So obviously Communicator comes with a very stylish looking model browser, but we added this other alternative model browser in the forum, which has some advantages. The main one is it deals a little better with first of all, you can have multiple of those in the scene. So it's customizable. You can add like a second or third model tree. Again, we're leveraging this in this initial demo I showed you, which is a pretty nice feature and I think fairly important in the BIM space. But it also handles relationships a little bit better. So if you click on any of these things, you get here this relationship data, and then it gives you essentially a little mini model tree for all the different entities itself. So if you're clicking on a wall, for example, it gives you the container spatial structure, story 7, and you can drill down on these individual entities here a little more easily. So again, a useful feature. And you should maybe just download and play around with it if you can. It's also dealing the properties a little more. It's organizing things. You can open and close them. It automatically makes sure that the units are correctly handled. It deciphers these the dates that are usually just show up as some numbers in our standard viewer. So it's in some ways it's doing a little bit better job with some of the property data than our built-in viewer. Okay, so now let's move on to the final demo, which has, as you can see, is still the searches in there, but the main feature is clash detection. So actually, let me go back quickly to our to the PowerPoint presentation here. Okay, advanced search, clash detection. So that's, I think some of you are using that. It's an interesting topic, a quite complex topic theoretically. And just to recap, there's basically 3 ways to do clash detection using HOOPS Communicator and leveraging the power of our technologies. 2 of them are doing this on the server, either leveraging HOOPS Exchange on the server, and we know at least 1 or 2 partners are going down that path. That means, of course, you have to have a PSC model with that model that is viewed on the client, and then you load it in. You're performing a clash detection using this function collision compute. The hard part is really figuring out the entity and making sure that the entities in the web view are aligned with the ones that you are doing this collision check with. In general, luckily for IFC, there's this unique identifier, the IFC GeoID, that you can use and that you have to parse, and again, then align the models based on that. Or you can also use the exchange IDs if you have a Revit model or other models where that IFC ID is not exposed. HOOPS Exchange is pretty good with collision detection. It's not perfect, so you might run into some problems and might give you the wrong result occasionally. So it's something you have to really evaluate. And yeah, there's certainly a certain level of complexity added to your application by having to run these server-side processes. The other approach is using Polygonica. That's a product that we resell, which is, of course, this like a tessellated, essentially like a modeler for tessellated data, and has a lot of analyzing capabilities. It can perform Boolean on the data. It can do all kinds of things with meshes. And one of the things it can also do is clash detection. It's very fast and it's very robust, but it comes at an extra price. It's essentially the deluxe version that if you want to add that, I think it's not part of, obviously, of the HOOPS web platform. And so you would need to buy that separately. And we haven't really, not sure if we have too much sample code on that available, but we can certainly help you with that implementation. And then the third approach is one that we have now worked on for the last couple of weeks. Again, it's an open source project around Communicator. It's going to be released in the next couple of weeks, which is a client side, doing it all on the client, essentially, and leveraging HOOPS Communicator, all the mesh data that's already in the client, to do the clash detection without server involvement. That's what I'm going to show you in this demo. Okay, let's start again. And we have our standard Arboleda model in this demo. That's already everything preloaded. And again, this has this clash detection library built in. So I can now just activate. Let me activate all the options here. And then it takes a few seconds, and then it evaluates all the clashes inside this model. And there's a little browser here that allows you to go through it. We can organize this. Let's find like a clash here, see all the individual clashes. And we can do this like auto zoom or X-ray. Let's do this here. It shows you here, for example, this is a real clash. This model is not very well designed for one reason or another. And so there's a lot of these like very blatant clashes in the model. Like, for example, this one here clashes with this one. We have a clash with a wall here. Where is this? Like, again, also, it doesn't look like we can now, let's look at this first. You see, like there's real clash here, and it finds it pretty reliable. You can set up so let me go over a few things. You can also look at the objects that are just touching. That's another built-in. So here, like these 2 items are just touching next to each other. It's another wall. Obviously, there's going to be a lot of entities that fulfill that criteria. And again, you can, of course, change this penetration distance. So there's a bunch of things you can set, similar to how the functionality that is exposed in other applications or other tools and in Exchange. So you can say like penetration distance, in this case, 55 means 5.5 millimeters are okay. So if a model is lightly penetrating, that would be not necessarily regarded as a clash. There's this touch check. There's some extra calculation required in order to do that. So that's why it's a separate setting. And then there's this in-share check. It can also detect if something is actually fully contained in another thing. So again, this makes this a little more sophisticated, takes a little longer to compute, but it's for this model, at least, it's also all done in a second or two. Okay, let's try some other thing here. So that is, I think it's useful. It works well. It's fairly robust. I mean, we've worked on this quite a bit. It's not perfect. I'm sure there are bugs, but we're gonna work on this a little more and make it more robust and hopefully as solid as some of these other server-side implementations. You can also evaluate it just for things. You click on a part, and then here evaluate for single node. Again, it clicks on it, automatically finds all these slabs here, which are these columns here, which are clashing with this particular part. And a bunch of other tools as well. You can also, instead of searching the whole model, you can also do like limit the search, and there limit the collision check only for like a subset, for like a group of entities. So let's take again the example of doors here. So we can leverage the search here, or you can have a list of types, for example, but we do this here with the search quickly. So let's see. These are all the doors in the building. We'll be setting those as the source and the target. So now we are evaluating everything that clashes with each other. And turns out there's actually no clash between any of the doors. However, there is another thing that we can assign, which is this like safety margin, which say, hey, give me also all the entities which are not clashing, but are within that safety range. So in this case, let's say like everything inside 1 meter of will be evaluated. And we can do this here. Oh, there's a. Let me do this again. Sorry, I have to. Let me actually. Oh, I pressed the wrong button. That now evaluates it for all the entities. I just wanted to see it for this. So give me a second here. Let me actually quickly reload this here to save a little bit of time. This calculation is a little more time consuming because it has to really potentially go through the whole model and then find the closest distance between a lot of entities. Let me do this very quickly again. So temp door. So let's find all the doors again, putting the here source target, and then we say distance of 1000, and you see here that also still happened very quickly. And so now it gives you the list of all of the doors that are actually close together. So again, we can put this here. You see they're within this one meter safety range, and you can, as you just sorted this by distance here. So if you go all the way down, you see like these doors are really close together, and this one is actually, these two are actually touching each other. So yeah, it has all the features built in. I think the key for clash detection is, of course, precision and not missing something. It's supposedly conservative, so it shouldn't miss any clashes. It might find a little too many in some scenarios, but I think the key is really making it robust and making it not miss important clashes. That will, of course, then make it somewhat useless. And yeah, I'm a little bit ahead of time now. Yeah, it's a lot. There is more functionality in here. You can do, obviously, can sort things, and I think it's very useful in combination, again, especially with the search, to really drill down and go through a model. And you can try different models. If you have like the really big models, like the hospital data set, it's gonna take around a minute. If you do a full clash detection on everything, it might take like in the range of 1 or 2 minutes to calculate that for really big IFC models. And of course, if you have some Navier-Stokes model that's even more gigantic, that number goes up. Important to note that you can run this on the server, of course. That is an interesting idea and approach that obviously you can run, and we're using the image server for that, but there's other approaches, basically using like especially in a Node.js context, you can use something like Puppeteer to run the Communicator client on the server, and then leverage all the APIs and all the capabilities to search through the model on the server. And then the client is the requirements on the client are not so high, and nothing gets gets blocked. And I'm working on something in this library to make it easier to do these calculations completely server side. Let me actually go back to my PowerPoint here. Okay. Oh, yeah. So the approaches, the client-side implementation, just to sum it up again, it can find hot clashes, has a tolerance, can specify the safety distance. Again, it's fairly accurate and quite fast, especially if we're running on the client. One caveat, and that applies to some extent also to the search, it's currently not working too well with the regular Streamcache streaming. So if you're not using SCS, but using the streaming mode and not using the mode where it downloads everything, performance is not great for the initial calculation, because it needs to pull the mesh data essentially one by one from the server. It's not, currently Communicator is not very optimized when it comes to like getting everything. And for the clash detection, it needs, of course, full access to all the triangle data. So that is slow. It's a feature. So there's some functionality we could add to make this go a lot faster. And again, you can do this on the server. You can have a separate SCS file, but that is, I think, one of the major caveats here. And of course, again, we're working on quality, fixing bugs, again, for clash detection, again, precision and not missing any clashes is, of course, super important. And so from my perspective, that's already it. If you have any particular questions on these various tools, whatever I talked about, just send me an email, or you can obviously ask questions in the forum at any time. But I think we want to open it up to questions, and we have two developers here as well. So yeah.
Yes, and we have quite a few of questions already hanging out in the Q&A. I think I have 5. So the first one I have here is, let's see, does support search for IFC only, or is it supported for all extensions and formats?
It's supported for all formats. And, this is AEC focus day. Especially the search works really well with mechanical data as well. And of course, certainly with Rabbit and all the other entities. It's doing it's doing some pre-processing initially to pull all that data out and put it in a hash table. So if you have a gigantic model, that would take a few seconds. But for the most part, it will work really well. And it's another interesting caveat there. It's because it needs all the property data, it has, similarly to the clash detection, if you're using the streaming mode, it takes a lot longer to pull this data out. That's why the search has actually an optimized you can basically save out the optimized structure that the search requires to a file and then load it separately in order to improve performance, especially if you're dealing with very large models or if you're using the Streamcache streaming. But yes, it's supported for all formats. And it works. You can really do some interesting stuff there if you have a mechanical model with some props. For example, some mechanical models have dates included, like when a certain part has been added or edited, and then you can very easily search that and organize it, and and color, for example, a cut model by the time the individual parts have been edited or created.
Thanks. And I think I already know the answer to this, but is the search feature and the clash detection provided in HOOPS Communicator 2023 SP1? I'm assuming that's no.
No, this is all stuff that we built around Communicator. And again, those two things will be released shortly. It's open source. They will be on GitHub and it will be advertised in the forum. And then you can kind of use them or change them or do anything. And yeah, that's the plan. Currently, there's no plans. And again, this is the caveat here is this is not official stuff, right? So this is something we developed for the labs. I wouldn't call it a proof of concept. I think we are putting effort into making these things really solid, but it's not an official part of the product. And yes, I think that's important to keep in mind.
Cool. I have a couple more questions. Okay. Do the Revit files show type properties for families and system families? Will search support finding objects based on type properties in Revit files?
Well, so it searches for all the property, every property in a Revit file is supported, or in any mechanical CAD file. So the answer is Revit has a little bit of a different structure than IFC, and of course, what Communicator and Exchange does, it tries to map things over. So, for example, from what I can tell, I looked at this just today, in Communicator, when you have a Revit file, it puts the category that is usually in other categories in Revit into the layers. And so I think that corresponds to the type. But so essentially, if you want to organize things by type or search by type, you would use in Revit, you would use the layers basically to do that, because that is the way it's mapped in Communicator. But yeah, every property that's available in the model is going to be exposed in the search.
Cool, thank you. Okay, another question for clash detection. How much accuracy can we consider in comparison with Navisworks?
So when I looked at this, when I did and worked on this clash detection, I did a closer look at Navisworks and how they implement it and some of the caveats that they have. The accuracy, obviously this is a big application, which one of its main focus is clash detection. So I'm sure they worked on this a very long time. But from what I can tell, and with the way the algorithms are implemented, it should be similar. When we release this, it should be again, our implementation is conservative in the sense it will not miss any clashes if you're setting the tolerance very low. And so I think that's similar to how Navisworks, I think, has two different modes. It has a conservative mode where it actually finds more clashes. I think it puts some sphere or circle around it on the triangles to make sure that even if something is only very close together, it will find it as a potential clash, and then you have to search through it. And yeah, it all depends, obviously, to some extent on the quality of the tessellation. And so I'm not sure, but that is usually baked into the IFC model. So yeah, I think it's pretty good with regard to that. Obviously, Navisworks supports huge models, and I think there's some, at some point you will reach to the limits of what it will take some time. I never used Navisworks clash detection. I don't know how fast it is and what the performance looks like. Again, you look at around 2 minutes for that big hospital data sets, which is a fairly big IFC model. But of course, Navisworks model can be, an order of magnitude bigger. And so we see that remains to be seen. There's some ideas around using multi-threading more aggressively. That would improve performance quite a bit, but yeah, still work in progress.
Okay, thanks, Guido. Let's see. The only other question I have is, will the recording be shared? And yes, there should be email that'll go out at the end, along with, I will post this in the forum, and the link to the forum is in the chat. So it'll be posted there, and you should get an email with a link to the full recording of this session. Guido, I don't see any other questions. Is there anything else you wanted to cover before I wrap things up?
Yeah, not really. I think, yeah, I mean, as a bottom line is, and I don't want to speak for product management here, but of course, AEC BIM is a big focus for TechSoft. We're going to keep investing in it. I think Revit is a focus. I think we're going to support drawings better in an upcoming version of the product. I think there's a general initiative now around performance, specifically geared toward Navisworks and these gigantic models that Communicator does support, but it takes time and things get slow and sluggish, and some you can't. So I think there's room for improvement on this huge data sets, and I think that's something that we're currently working on. I know that we are supporting we are in the process of implementing, I think, DGN as it's another format. So that's interesting. I think we have, again, a lot of bug fixes and improvements under the hood. There's more to come, basically, on BIM, for sure. besides all this work that we're doing around Communicator. And again, we've just showcased today a little bit.
Thanks, Guido. And I will say I ran a couple of the polls while you were talking, and it looks like most people in our audience aren't using clash detection currently, but want to. Would you have any suggestions for them on where to start if they're looking to get started?
Well, once again, I think there's different approaches to take. Well, you can use, if you use the exchange approach, it is a bunch of work, but I think that is our official solution for this right now. That's fully part of the product, and I think already implemented by some people. Again, you can wait a couple of weeks. You can try out this client-side clash detection module. You can also do some, go to some third party. Again, and Polygonica is another good option. I think there's other solutions probably as well. But yeah, stay tuned. It's going to be released soon, and then at least it's a good comparison as well, I think. And certainly it works great on these moderately sized models. And